In 3.5, we're going to take a look at a couple of fairly simple ideas that will help us to find the rational roots or find all of the roots of any polynomial. So the first thing that we're going to do is look at the information that you need in finding rational roots. Basically, anytime that we've done standard form, our lead coefficient we've always identified as A, and the constant we've always identified as, if it's quadratic, we would identify it as C. If it's cubic, we would identify it as D. Well, when we're finding the rational roots, we're going to identify the lead coefficient as Q and the constant at the end of the polynomial as P. So what we want to do to be able to find out what are all of the possible rational roots of any polynomial, we're going to take all of the factors of P and we're going to place those over all of the factors of Q. So any combination of these factors is going to be a possible rational root. And need to mention that it's going to be both the positive and the negative version of that rational. So if we take a look at the first problem, we're asked to find a rational root of 2x cubed minus x squared plus 2x plus 5. And we're going to find all of the possible rational roots. So the first thing that we want to do is identify what is the value of P and what is the value of Q. Well, P is equal to 5 and Q is equal to 2. What are the factors of P? The factors of 5 are 1 and 5. The factors of Q are 1 and 2. So now we're going to put P over Q. And we'll start with P. We'll start with the 1. And we'll put 1 over all of the factors of Q. So when you put 1 over the factors of Q, you get 1 over 1, which is 1. So we're going to do plus or minus 1. Then we put 1 over 2, so we get a half, and it's going to be plus or minus 1/2. And the next thing we're going to do is we're going to take a look at 5. Put 5 over 1, so that's 5, so plus or minus 5, and then 5 over 2, which is plus or minus 5 over 2. In problem number 2, we're going to do the same thing, but we're going to do it with a little bit more complicated numbers. So we've got 15x cubed minus 32x squared plus 3x plus 2. So again, identify what P is. P is 2, Q is 15. So the factors of 2 are 1 and 2. The factors of 15 are 1, 3, 5, and 15. Now I can tell you that you never want to see any number besides 1 for Q. It's just going to make everything more complicated. But as of right now, all we're doing is identifying the possible rational roots. So again, we're going to take our 1 and place it over 1, 3, 5, and 15. Take the 2 and place it over 1, 3, 5, and 15. And you're going to have plus or minus each of those. So that works out to plus or minus 1, plus or minus 1 over 3, plus or minus 1 over 5, plus or minus 1 over 15, plus or minus 2, plus or minus 2 over 3, plus or minus 2 over 5, and plus or minus 2 over 15. So as you can see here, we've got 16 possible rational roots. So even though we might think that there's an infinite number of solutions or an infinite number of possible solutions for 15x cubed minus 32x squared plus 3x plus 2, it's actually going to come down to those 16. If we have any real solutions, it's going to be one of those 16 there. So we've taken an infinite number of solutions and we've narrowed it down to 16. Okay, we've got a really simple idea here. We're going to use the conjugate root theorem to identify roots. Anytime that we have an irrational number or we have an imaginary number that we know is a root or a zero or a solution of a polynomial, then we know that there has to be a second one that's paired up with it. And it's always going to be, one is going to be positive and one is going to be negative. So they're conjugates. So if we know that the square root of 2 and 1 plus I are known roots of a polynomial, then we also know 2 other roots of that polynomial. So if you've got square root of 2, then another root has to be negative square root of 2. If you have 1 plus I, then the conjugate of that is 1 minus I. 1 minus I has to be a root of that polynomial. So just by knowing square root of 2 and 1 plus I are roots, we get 2 more roots, so we know 4 possible roots for that polynomial. Okay, in problem number 4, we are asked what is a cubic polynomial function with rational coefficients with roots of -4 and 2i. So since it's a cubic polynomial function, we know that there have to be 3 values of x. Right now we're given 2. We know that x is equal to -4, and we know that x is equal to 2i. But with our conjugate root theorem, we know that 2i, since it's an imaginary number, has to be part of a pair. So it's going to be the conjugate of that. So we know that -2i is also a root for this cubic polynomial function. So we write out our zeros, x equals -4, 2i, and -2i. The next thing we do is we're going to take those x values and we're going to plug them into 3 factors of x minus a. And all we're going to do is replace a with each of the roots or zeros that we already know. So if we plug in -4 into x minus a, we get x minus -4. Well, negative times a negative is a positive, so that factor becomes x plus 4. If we plug in 2i into x minus a, then we get x minus 2i. If we plug in -2i into x minus a, then we get x minus -2i, and again, 2 negatives gives us a positive, so x plus 2i. At this point, since we've got these in factors, what we want to do is go ahead and start foiling this. My recommendation again would be, since you've got conjugates, x minus 2i and x plus 2i, start with those. Because we know that whenever we multiply conjugates together, we're going to drop the o and the I out of the FOIL. All we have to do is the f and the l. So when we do that, x minus 2i times x plus 2i, we get x squared minus 4i squared. Pull the x plus 4 straight down, and you can see the 2 factors that we've got. Now we need to take care of that I squared. And remember that I squared is the same thing as -1. So we get x squared minus 4 times -1, which is x squared plus 4. So now we've got the factors x plus 4 times x squared plus 4. Again, distribute, FOIL, and we're going to end up with x cubed plus 4x squared plus 16. If we can, combine any like terms, which there are no like terms, but go ahead and put this into standard form, and you end up with y equals x cubed plus 4x squared plus 4x plus 16. The next bit of information that you're going to need to be able to solve polynomial equations is Descartes' rule of signs. Now, in my experience, this is helpful, but it does not always work. But again, it's helpful. So if you have a lot of possible rational roots, it's going to give you an idea of how many of those roots there are, or there possibly could be, or likely are. So the way that we accomplish this is we first look at what are the sign changes in our polynomial equation. So let's just say that we're given positive ax to the 4th minus bx cubed minus cx squared plus dx minus e. We don't need to worry about the coefficients because they absolutely have no bearing on what we're doing here. What we want to do is we want to look at the signs. Every sign change tells you that there's a possible rational positive root. So if we go from positive ax to the 4th to negative bx cubed, that's one sign change. Then we go from negative cx squared to positive dx, that's a second sign change. Then we go from positive dx to negative e, that's a third sign change. Now what this tells us is that there's a maximum of 3 positive roots. Then what we would do is, knowing that imaginary roots and irrational roots come in pairs, we would subtract 2 until we either get to 1 or 0. So if you've got 3 possible rational roots, or positive rational roots, subtract 2, that gets you down to 1. So we could either have 3 positive roots, or we could have 1 positive root. Now, if we want to figure out how many possible negative roots there are, what we're going to do is we're going to substitute -1 in for all of the x's. So you can see that we've rewritten this as positive a times -1 to the 4th, negative b times -1 cubed, negative c times -1 squared, plus d times -1 minus e. When we work that out, again, we're not worried about the coefficients, we're just worried about what is the sign. So -1 to the 4th is a positive, times a positive is positive. -1 to the 3rd is a negative, times negative b gives us positive b. -1 squared is positive, times the negative c gives you negative c. Positive d times negative 1 is negative d, and then we already have negative e. So we can look at this and we can see that we have one sign change going from positive b to negative c. So this tells us that there's going to be one possible negative root amongst all of our rational roots. Now we'll use Descartes' rule of signs to determine how many possible positive roots and how many possible negative roots there are for a polynomial equation. So we've got x cubed minus x squared plus 1 equals 0. So already, since it's x cubed, we know that there's going to be three roots. Now they could be positive, negative, or irrational, or imaginary. What we're going to do is we're going to figure out how many positive possible ones we've got and how many possible negative ones we've got. So looking at x cubed minus x squared plus 1, we have a positive out in front of the x cubed. So positive x cubed to negative x squared, that's one sign change. Negative x squared to positive 1, that's the second sign change. So we know that there's the maximum number of positive roots that we've got is 2. Now, it's also possible that we don't have any positive roots, because what we're going to do is we're going to say 2 minus 2. So 2 possible imaginary or irrational roots would then take us down to 0. So we could have 2 positives or we could have 0 positives, because those 2 positives, or the place for the positives, might actually be taken by imaginary or irrational. This will make more sense when we get to the next section and we actually start doing all of this. Now, to figure out the negatives, the negative possible roots, we're going to plug in negative 1 for each of our x's. So negative 1 cubed minus negative 1 squared plus 1. And all we care about is what are the signs. So negative 1 cubed is negative 1. Negative 1 squared is positive, but times a negative gives us negative 1. And then we bring down the positive 1. So we have one sign change from negative 1 to positive 1. So that one sign change tells us there should be one negative root. So when we get to actually solving this stuff, we would want to start with the negative root because we're pretty sure that we've got at least one.